Hello everyone, welcome to this video. In this video, we'll be looking at another question from IIT-JAM Mathematical Statistics paper 2020 and 20. This is a 2-mark question and this is a multiple select question. So that means here we could have multiple options as the correct option. So here in this question, they are saying if you are given some matrix M, this matrix M is given to you, and further it is also given that this is an orthogonal matrix, right? You know, for the solution, what is an orthogonal matrix? For an orthogonal matrix, a matrix M is said to be an orthogonal matrix whenever you have either M transpose, that is as an identity matrix, or you have M transpose time multiplied with the matrix M, that would give you the identity matrix of the same order, right? So this is what you have the result for orthogonal matrix. So in this case they are saying this matrix M is given to be an orthogonal matrix, then which of the following statement is true? So here you see in the options you are given certain relations among A and B. So we need to check what are the conditions that we obtain when we apply this condition of orthogonality to the given matrix M, right? So let's start and solve this question. So here we have M as the given matrix 1 by square root 2, 1 by square root 2, A and B. So what we can do, we can calculate the transpose of this matrix. So M transpose, that would be obtained by just exchanging the rows with the corresponding columns. So the row in the matrix M is now become the first column here, and the second row here became the second column, right? So what now we have two conditions, we have to check for both the conditions. So let's first of all apply the condition that as the matrix M is orthogonal, right? So therefore we have therefore you have M into M transpose, that is equal to identity, and we also have M transpose M, that is equal to identity, right? So here first of all let's calculate M transpose is equal to I, the identity matrix. So the matrix M is 1 by square root 2, 1 by square root 2, and here it is A and B, and its transpose, that is 1 by square root 2 A, 1 by square root 2 B. This is the matrix. So this is equal to the identity matrix 1 0 0 1 of order 2, right? So let's solve this one. So it is simply equal to, when you multiply the first matrix with the second matrix, so it would be equal to 1 by 2 plus 1 by 2, that is 1 only, right? And then you have the next entry as this element, this row into this column, right? So it is A by square root 2 plus B by square root 2, and for the third one it is this row multiplied with this column. So it is again A by square root 2 plus B by square root 2, right? And the last one is this row multiplied with this column. So it is A square plus B square. So this is the left hand side matrix, and the right hand side matrix, you know, is the given identity matrix, right? So let's solve this. So when you compare this, so you obtain A by square root 2 plus B by square root 2, that has to be equal to 0, and you also have A square plus B square as equal to 1, right? On equating two matrices, on equating the above matrices, right? So you obtain these two conditions from here. So from the first condition, what do you have? You could take out 1 by square root 2 common from both of these, so that you have A plus B as equal to 0. And from the second condition, you have simply have B square is equal to 1 minus A square, or you could write this to be B is equal to the square root of plus minus the square root of 1 minus A square. So these two conditions are there when we apply this condition of M transpose, that is the identity matrix. So from here you see your option A is correct and your option B is correct. Now let's go and look for this second condition over here, M transpose M is equal to I. Do we end up at some other condition, right? So let's see. Also, as M is orthogonal matrix, that is given to us, right? Because M is orthogonal matrix, therefore we also have we also have M transpose M, that is the identity matrix. So let's write down the transposed matrix. So that is 1 by square root 2 A, 1 by square root 2 B. This is the transpose matrix. And what is the matrix M? It is 1 by square root 2, 1 by square root 2 A and B. So let's just all of when we multiply them, that is equal to the identity matrix. So let's just solve this one. So when you solve and multiply this one, so you multiply this row with this one, so that you have 1 by 2 plus A square. The second is when you multiply this row with this column, right? So you have 1 by 2 plus AB. The third one is you multiply this row with this column, so that you have 1 by 2 plus B square, right? 1 by 2 I'm sorry, not B square, it is 1 by 2 plus AB, and the last one is 1 by 2 plus B square. On multiplication you obtain this kind of matrix. You have 1 0 0 1 as such. So you see, when we equate on both sides, so equating both the matrices above, we obtain 1 by 2 plus A square is equal to 1. We obtain 1 by 2 plus B square is equal to 1, right? And we obtain 1 by 2 plus AB is equal to 1. So you see, from here, from the first condition, we obtain A as equal to A square is equal to 1 by 2, B square is equal to 1 by 2, and from the third condition we obtain AB as equal to 1 by 2, right? AB as equal to 1 by 2. I'm sorry, this half plus AB, that is not equal to 1, but it is equal to 0 here. Yes, so it is equal to minus half, right? So you see, we obtain these two few more conditions on A and B. So let's go and look back our options. So here you see option C is also the correct option. The rest two option about A square and B square, they are not given to us directly. So you see, we have the option A, option B and option C as the correct option. However, in the answer keys, they have only given you A and C as the correct option, but according to me, option B is also the correct option. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.